All right, so we're going to finish up this unit looking at 4.1, looking at quartiles, and then looking at the misuse and use of the data and how it's presented. So with 4.1, we have box and whisker plots, and those are just ways to look at breaking up your data. So the textbook goes into more examples and explanation, but I just wanted to give you a quick visual of what a box and whisker plot looks like so that you can quickly visualize where all your data falls. So your two dots at the extremes are at your lowest number and your highest number. At your median of all your values written in order will be your quartile 2, your second quartile, so that's at the 50% mark. And then your Q1 and your Q3 are the 50% marks of the other 50%. So breaking it down into 25% increments. So if we have these 7 values, 7, 3, 14, 9, 7, 8, and 12, we need to rewrite them in order of least to greatest. So we can see that we have 3 numbers, then we have the number 8, and then we have another 3 numbers. So on a number line, drawing your box and whisker plot, we have the 3 and we have the 14. We then can see that we have our median, our Q2 is at the number 8. Of our 3 numbers below our 50% mark, we have the number 7, and above we have the number 12. So that forms our box of the middle 50% of data, and the lines outside the box are the other 50%. So if you're in the value of 3 to 8, you're in the lower 50%. If you are below 7, then you're in the bottom 25% of the information. If you are between the 8 and the 14, you're in the upper 50%. If you're above the Q3, then you are in the top 25%. So this is when they look at information like growth rates and that sort of thing, looking at the development of infants and comparing them. And so that's what a box and whisker plot looks like. So next we have 4.5, the use and misuse of data. So once you've collected your data, you need to display it. You can pick a format. Key thing, all your graphs must include a title, labeled axes, and if you're using a pie chart or a pictograph, you need a legend explaining what your images look like and what they stand for. From the display, you should be able to make conclusions and assumptions. Conclusions can find relationships between variables or non-relationships. Causal relationships are when one variable directly affects the other, but you need to be careful not to turn relationships or common answers into causal relationships. So on page 23, number 12 is an example of that. And actually, I'm not sure if that's from this textbook that we're using now. So I have some links to some videos about misleading graphs so that you can clearly see where you have to be careful. But let's just look at some quick examples and determine some conclusions that we can make and why these graphs might be misleading. So if we look at this one, so I'll enlarge that, okay? And we're looking at PS3s. And so this is basically, you might have that the title of this is that PS3s are more popular than Xbox 30s. Notice it's not that they're bigger, it's that they're more popular. So they're using bar graphs and they're using the image of the machines. So why might this be misleading? Well, if you actually look at the data, an Xbox 360 is at 46%, whereas a PS3 is at 49%. So that's only a difference of 3. But when you look at the graph, it looks so much bigger. And the reason is because the scale they've used. They've used a scale starting at 4.45. So your whole scale is only a value of 5 units. So that's very misleading. When we look at the second example, average ticket prices, again, what might we determine from this? Looking at this, we might think that basketball prices are over 2 or 3 times more expensive than hockey, and that baseball and hockey are the same. We have to be careful of looking at our scales and what the images are saying. Are they representative of the actual data, or are they misleading? So in this case, this might be indicating that a basketball ticket price is maybe $38 versus baseball being maybe $15, $16 to $18, and hockey being $15 to say maybe $17. So them being pretty comparable. But I think in fact nowadays you're not going to see hockey prices being less than basketball. They're usually quite more expensive than the basketball. And so when we look at here the average ticket prices, you can see the scale again here. What's the difference between this average ticket price versus this average ticket price? So notice what the scale is here, and then in C, what's the scale? So notice they jump from 0 to 20 and then by fives. So you have to pay attention to what your scales are and what the actual readings are. So this is still saying maybe $37, $38, and these are also saying maybe $17, $18, but your scale is very, very misleading.